So now some differences between Linux kernel versus normal C application coding. Uh, First, the kernel has absolutely no access to the standard C library, nor the standard C headers. So that basically means that anything, because the kernel is the lowest level of C code that you can have on your computer. Uh, Anything lower, you're going assembly basically. So there, how do you develop the system that the Linux system? So parts of Linux or very small parts have been written in assembly, but we'll go through it. But in general, the Linux kernel does not support the full-fledged C library. Uh, the kernel is coded in GNU-C, and there's a difference between GNU-C and ANSI, which is probably most of you are familiar with, or more familiar with. ANSI is sort of like the standard C that most people use. The kernel lacks the memory protection that user space has. So in kernel mode, you can touch any part of memory. If you are coding for the kernel, if you're writing code for the kernel, you can basically mess up things very easily because you can just destroy your memory content. There are no floating point operations, so you shouldn't go crazy with divisions and multiplications and exponentials because the kernel is meant to be simple. It's not meant to do complex mathematical operations, and floating point operations are just a pain. You have a small per process fixed size stack for each kernel process because the kernel itself will have multiple processes running. So you have the network process, you have the or process for the network, you have a process for this, a process for memory management, and so on. So you have a small per process fixed size stack. It does not change. It's different from the user space. Because you have asynchronous interrupts, because basically while you're running in the kernel, you can basically have an interrupt because something happened. There is a timer interrupt. There is something that got connected to your system. So it does. It is preemptive and it supports SMP. For more on SMP, you can just check the Wikipedia pages on SMP. It's not something important in general that will affect any of your understanding of what I'm going to talk about next. Uh, Synchronization and concurrency are major concerns. You want the kernel to be synchronized and concurrent. So because you have multiple things going on in the kernel at the same time. The kernel is not just a single process. It's not just a simple it's not just simply the scheduler. You have the network you have the network subsystem, you have the memory management subsystem, you have the file system. All of these require synchronization and concurrency, and because sometimes it might result. I mean, just the order of the operations that you would do might result in errors. So, for example, suppose that you're reading a file from a network from the network. You can read files from the network, and that basically means that you're going to use the network subcomponent, you're going to use the scheduler, and you're going to use something like block IO. And if you're basically do things in the wrong order, you will end up wasting time because, well, if the packets do not arrive from the network first, you're reading the file across the network, for example, through Google Docs or something. If the packets do not arrive through the network first, well, if you run the process for the block IO, there's nothing to do there for it, right? And then portability is important. As we said, we want the upper levels, the upper layers of the kernel to be exactly the same for all platforms, for all architectures. So if I'm using Linux on my AMD, it shouldn't matter if from using Linux on my Intel device, which basically means that it's portable. The only layer that changes in that case is the hardware abstraction layer, the HAL layer, and this we're not going to talk about in a lot. Um, so as we said, there are no libc and no standard headers. The full C library is basically too large and too inefficient for the kernel, so they decided that they're just going to re-implement whatever they need from the standard C from library into the system. And these are the kernel headers folder that we were talking about in the beginning, the headers folder. And for example, they re-implemented the crypto part, but not everything. So many of the usual libc functions are implemented inside the kernel, but not all of them. Common string manipulation, for example, is in lib/strings.c. So if you go to lib/strings.c, which might actually help you with well, I wouldn't say it would help you with the current assignment that you have, but it might give you some inspiration. So if you look, if you go to lib/strings.c in the kernel directory, in the kernel, well, no, I shouldn't say the kernel directory, in the kernel tree, basically, you will see all string manipulation functions implemented there. And if you're calling it from anywhere inside the kernel, then you just need to include the header file linux/strings.h. Okay, so this is where your header file is. Any architecture-specific header files are located in the architectural in the arc directory, and then slash, and then the architecture name. So if you are, for example, looking at there are multiple, there are different architectures. So if you're looking at ARM architectures, you'll find that there is a folder that is arc/arm/include, and you'll find some architecture-specific header files only for ARM processors. And ARM processors are most of the processors we use, for example, on our mobile phones or in many embedded systems. So this is, I mean, it's very clean, it's very elegant when you look at how the code is structured. It's beautiful, actually. But yeah, you need to figure out your way through the 25 million lines of code that you download when you're downloading the kernel. Since libc is not there and standard C library is not there, printf is non-existing, and well, simply put, printf in the kernel doesn't mean anything. And they have instead something that's called printk. It's the kernel's implementation, print kernel basically. It's the kernel's implementation of the printf that exists in normal C. And this will be your best friend in debugging, because, well, this will throw things out, and we'll know where it will get thrown out later. But this is like your best buddy when you're doing kernel programming. So for the assignments that for the project, the large kernel project, and for implementing the syscalls to debug, you need to use printk, not printf. There are other ways to debug in the kernel. I'm not going to go through them through the course, but you're most welcome to basically read on debugging in the kernel. Then you'll find plenty of information on how to do that. And there are very, very nice ways to do that. Printk allows you to set a priority flag, and this priority flag is basically kern error, for example, is one priority flag. So printk kern error, this is a priority flag, this is an error. Okay, and you do not have a comma between the flag and your message, because if you're so used to most higher level programming languages, you might have a comma there. This is actually an example from hibernate.c, the file hibernate.c, which is in the subfolder power, which I believe is in the kernel folder. Hibernate.c is basically your system hibernation file. Okay, so when you basically you're on your computer and you say sleep or hibernate, this is the file that you go to. And I wasn't going to read like the whole code, because it wouldn't make sense. But this is basically the function that is used to create an image of your platform. That doesn't mean anything, but it's just the function that's used to create the image before you hibernate, that will then be stored. And when it is stored, this is basically hibernation. You can read more about hibernation. This is not our thing now. But I just wanted to give an example of how it is used inside the kernel. So this is real code from the kernel, and if error, you print kernel error PM, some devices fail to power down. And you might You might have seen similar um, error messages when you're restarting your computer, and there are some or when you're doing sleep or hibernate, and there are some applications that just wouldn't quit. So this is actually something that you can easily find. And I have to say that these slides were prepared on a previous version of the kernel, basically 1 year old version of the kernel, which I have on my computer and my laptop. I have not updated it. I think most of the functions that I will point you to, and most of the code that I will point you to, does not change, if not all of it. But if you do basically try finding this code and do not find it, please ping me, because I would really love to know that. It's very hard to keep up basically updating your kernel versions for development purposes because they have like a version every few months, and it's just very hard. So GNU-C uses GCC. What is the difference between the C's and between C99, ANSYS-C, and GNU-C? These are two Stack Overflow, or this is one Stack Overflow question, and this is a Linux questions forum also, which answers this to full details. I think you might want to take a look. It's just if you're a C programmer, just to know what is the difference. We'll just look at few differences very quickly. For example, there's this concept of inline functions in the kernel in GCC and GNU-C basically, and these are basically ways to make the compiler understand that there are better optimizations to be done. So inline functions are a property of GNU-C, for example, and the point of making a function inline is to hint to the compiler that is worth making some form of extra effort, extra optimization to call this function faster than it would otherwise. And this would basically, I mean, if you know how calling happens, if you have taken a compiler's class or that, then you might know this. Again, this is irrelevant to actually well, I wouldn't say it's irrelevant. It's relevant to know a bit about compiling, but it would not really affect your ability to run and do the projects. Okay, so this is just an example. I don't expect you to be writing inline functions, but you will be reading them through the code. And this is, to cut things short, it's an optimization. It tells the compiler, please copy the code here instead of basically jumping, making the program jump. Thus eliminating call and return sequence. It's just a way to make optimizations, and this is an example of such an inline function. And the k times set, it's basically a way to set the internal representation of time in nanoseconds. It's a central part of the kernel because I mean, timing is one of the central parts of any kernel, and it controls this. Just to, if you look at like the function that is down in the last function, static inline k time t, k time set. This is basically a function that the kernel tries, that the compiler, when compiling, tries to optimize as much as possible, because this is, and you do that for very central functions to your system. Basically, you want them to compile faster and run faster. And you might have even inline assembly. Will not be using any assembly in the course. I do not want you to know any assembly in the course. But this is just an example so that you might just know about it. There is a file that's called pm.c, which is basically a way to prepare the machine for transition to protected mode, basically transitioning from user mode to protected mode. And if you look at static void real mode switch hook void, the only function actually that you can see, you will see that ASM volatile. ASM is basically a directive that tells the compiler that what follows is going to be assembly code, and this is inline functions. And then this assembly code will be completely dependent on the actual um, hardware that you're running on. I have a note here that CLI is not anything that it's basically clear interrupt flag. So assembly volatile clear interrupt flag, CLI, is just to clear the interrupt flag and stop either enable or disable interrupts. Okay, so this is just for because you hit these lines ASM, so now you know what ASM will mean inside the kernel.